Hello everyone, in this video we are just going to interface LED with our STM32F446RE microcontroller with the help of common CMSIS file provided for this particular STM32F446RE microcontroller from silicon vendor, that is the ST Microelectronics. Let's get started. So till the previous video we were just writing down our program by our own without using any CMSIS file from any silicon vendor. So I'm just opening the previous program that we have written. You can clearly see this is the LED blink program that we wrote. And for this particular program we just created two different header files. One is the header file required for using the GPIO peripheral of the microcontroller, and another one is the header file required for using the RCC clock peripheral of the microcontroller. Let me just open these two header files. So I hope you watch this particular video in which we wrote this program. So if you have missed that video, I hope you will not understand this particular video. So I highly recommend you to watch that video and then come back to this video for better understanding. So in that video we wrote everything from scratch, each and every line from scratch that is available in this program. So please watch that video and then come back to this video for better understanding. So you can clearly see in this particular GPIO.h we have written our own structure definition for GPIO peripheral, and we can use this particular structure definition for any GPIO in our microcontroller. And in this clock.h we have declared the structure for RCC peripheral of the microcontroller, that is the clock peripheral of the microcontroller. So in this particular video what we are going to do is we will not be using these two header files that we created. Instead we will be using some CMSIS file, that is the Cortex microcontroller software interface standard file provided as a common source from the IC manufacturer, that is the ST Microelectronics. So for this particular STM32F446RE microcontroller, or as a common source for STM32F4 series microcontroller, ST Microelectronics, who is a silicon vendor for STM series microcontroller, has provided some common CMSIS file, and that particular CMSIS file will be containing all the structure declarations and pointer definition and declaration required for each and every register in the microcontroller. So we will be neglecting these two header files that we wrote in previous video, and we will be utilizing some common CMSIS source from the IC manufacturer for writing down the same LED blink program in this video. So this is what we are going to do in this video. So let me just create the project in Keil Microvision IDE first. Now I am just opening the Keil Microvision IDE. So here, once the IDE is open, just click on the project tab and click on new Microvision project for creating your new project, and move to the respective folder where you want to store your project in your local, and provide a name for your project right over here in the file name tab, and then click on save. And in the next consequent tab that is popping out, you just want to select the microcontroller that you are working on. So in our case the microcontroller is STM32F446RE. Just type in the microcontroller name. I'm just typing in like STM32F446 in the search box, and here you can see you are getting the microcontroller that you typed in the search box. Just click on the plus icon near the microcontroller, and here our microcontroller series is STM32F446RE. Just click the plus near the STM32F446RE and select the microcontroller right over here inside that tab, and then click on OK. And in the next manage runtime environment tab right over here, you just want to select the CMSIS driver and the startup code required for the microcontroller. So just click on plus icon near the CMSIS right over here and check this core right over here. And after selecting this, click on the plus near the device and then click on the checkbox near startup for generating the startup files required for the STM32F446RE microcontroller, and then click on OK. You can see the project has been created right over here in the project pane. Just click on the plus near the target for revealing all the project files, and then right click on the source group and click on add new items to group source group 1, and here I just want to create my main.c file required for the project. So click on the .c format right over here and provide a name for your file that you are creating in the name search box right over here. So I'm just typing the name of the file that needs to be created to be main.c. Just type in main since we have already selected the extension to be .c, and then click on add button right over here for adding the main.c file to your project. Click on the plus near the source group 1. You can clearly see the main.c file has been created to your project. And as a first step, we are just going to create or write down our main function. So I am writing like int main of void. So this is the main function which will be containing the logical part of the program which needs to be executed in our microcontroller. And inside the main, I am just going to create the while of 1, which is the infinite loop of the program. So this while of 1 is nothing but a never ending loop or infinite loop or super loop, whatever you call it. This is an infinite loop which will be containing the logical part of the program which needs to be executed again and again until the microcontroller is stopped. And the portion of the program just before the while of 1 inside the main function will contain the configuration lines of the program which needs to be executed only once in the lifetime of the program initially. So there are two segments of an embedded program. One is the configuration segment and another one is the infinite segment. So in configuration segment before the while of 1, we will be writing down the configuration lines such as, for example, configuring a port, configuring timers, configuring communication protocols, etc. Just before the while of 1. And another segment is nothing but the logical segment which needs to be executed again and again until the microcontroller is stopped. So that part of the segment or that part of the program we will be writing down inside the while of 1, which is the infinite loop of the program. That's all about the main function creation. And now I'm just going to add the header file required for the project. So has include of STM32F446.h. So we can either use this particular common header file STM32F446.h, or you can use another header file available which is particularly meant for this STM32F446xx.h, which is particularly meant for this particular STM32F446RE microcontroller or any other STM32F446 series microcontroller. So I am just going to use this particular header file which is available specifically for this microcontroller, and that's it about the initial configuration needs to be done in Keil Microvision IDE. So once you are done with the main.c source file creation and all the main function creation right over here, I just want to do some basic configurations required for interfacing the board to our microcontroller, that is the Nucleo board or any other custom made STM32 microcontroller based board to your PC. Just click on the options for target icon right over here and click on output tab in this particular window shown right over here and check this create hex file checkbox. That's it. Now click on OK. Save the configuration, and now let us start writing our logical part of the program as per our requirement. So the project has been created successfully, and we have included the CMSIS header file from the silicon vendor or the IC manufacturer, that is the microcontroller manufacturer. And the LED that we are going to interface to the microcontroller is the onboard LED that is available in the development board, which is connected to PA5, which we already discussed in the previous video itself. So let me just open the previous video program that we have written. So now I'm just going to copy this delay function to my new program. I'm just pasting it right over here below the hash include and above the main function. And I'm copying all these things. I'm going to paste it above the while of 1. Deleting all the comments. So I have deleted all the comments. Now I'm just going to copy all these blinking process inside the while of 1, and I'm going to paste it right inside this while of 1. So you can clearly see there are some errors thrown right over here. Let me just see what is this error. No member named AHB1ENR in RCC type def. And this error seems to be no member named OSpeedER in GPIO type def. So this particular program, which we wrote in the previous previous one of our video, is containing all the names and definitions, all the namings of the structure variables and structure elements as per our user defined standard. So we just declared this particular structure, and we just declared this particular structure, and we named the pointer to be so and so, this pointer so and so, and this pointer also so and so. So this is a user defined declaration and definition as per our knowledge. But here we have included this particular header file, which is from the common CMSIS source from the silicon vendor or the IC manufacturer. So when you are using this particular common source, so when you are using this type of common source of CMSIS file, you just want to follow their standard and not our standard. So let me just open this header file. Just right click on this and click on open document. And what I want to do here is I just want to find out the respective register name available for this AHB1 ENR register and OSpeed ER register. Other than that, all these registers such as CR, mode R, type R are common. You can clearly see these registers are not throwing me any error. Also this ODR register, this is also seems to be common between our definition from the previous video and also the CMSIS definition right over here in the CMSIS file provided from the silicon vendor. So let me just find out the GPIO register structure declaration. Just type in, it is hard to find if you search like this, GPIO. You can clearly see this is the GPIO structure declared, and here the O speed R seems to be the register name for speed register. So let me just copy this, but in our definition we have done like O speed ER. That is why the error is thrown. I'm just pasting it right over here. You can see the error has gone, and the pointer that has been declared and defined for GPIO A is common between our declaration definition and the CMSIS declaration definition. You can clearly see it is not throwing any error. Let me just type in this. GPIO A is meant for GPIO A base, GPIO B pointer is meant for GPIO B base, and so on. GPIO C, D, E, F, G, and H. You can use any of these pointers for configuring and using GPIO peripheral of so and so ports. And here let me just find the AHB1 ENR register name properly from the structure declared. So let me just search like RCC. So here is the RCC structure declared, and here I just want to find AHB1 ENR. Here it is. It is like AHB1 ENR in a consequent characters, but here I have provided like AHB1 underscore ENR. That is the problem. And that's it. That's all about the program that you need to write for blinking the LED. We have already discussed about this particular program many times in the previous video itself using our user defined CMSIS structure. So let me just compile this program. Just click on F7 in your keyboard or this particular icon in the top of the menu just below the save button for compiling this program. You can see the build is compiled with 0 errors and 1 warning. The warning is just because there is no new line at the end. Now when I compile, you can see the program has successfully compiled with 0 errors and 0 warnings. Now just click on this options for target and click debug and click on output tab and check this create hex file tab. And my Nucleo development board, that is the Nucleo F446RE development board, is already connected to my PC through USB cable, mini USB cable. Just click on this options for target and click on this debug tab, and in this particular drop down available right over here. Before that, you just want to select this radio button. If you select this particular radio button, the simulator will be turned on. No hardware will be connected, only the program will be simulated inside the Keil Microvision IDE without any hardware. So select this use radio button and click on the drop down box right over here and select ST-Link debugger and click on the settings near to it. You can clearly see, you must see this particular ID right over here. If it is not visible, your connection between the Nucleo development board and the PC is not proper, or there is some problem with the Nucleo or microcontroller connected to your PC. So just make sure that you see this particular ID like this, some ID. There should be some ID shown right over here. If there is no ID shown right over here, it is pretty sure that the board is not connected properly to your PC. Click on OK and OK. Now for dumping the flash to the microcontroller, just click on this download button or F8 in your keyboard. The flash has been successfully dumped to the microcontroller. Now let us check the output in the hardware. Since we are going to utilize the onboard LED that is available in our Nucleo development board, which is connected to PA5 of the microcontroller, we don't need to do any external hardware connections or build any circuit. We can just directly visualize the output in the hardware. Now I'm just going to reset the microcontroller. You can see the onboard LED is blinking in my Nucleo F446RE development board, which is connected to PA5 of the microcontroller. So we got the same output which we got in the previous video, where we defined and declared the structure for CMSIS structure for GPIO peripheral and RCC peripheral in that particular video. But in this video we just utilized the CMSIS file from the silicon vendor, that is the ST Microelectronics. So we successfully wrote the program for blinking the LED using CMSIS file from common silicon vendor, that is the ST Microelectronics, and from here on we will be utilizing this particular CMSIS file provided from silicon vendor, because this is very important. That is, you must learn how to utilize the CMSIS file provided from the silicon vendor, so that you will be able to program any microcontroller using CMSIS file provided from the silicon vendor, other than creating your own CMSIS file, because that is consuming a lot of time. But in terms of knowledge, it is very important. You must understand deeply what is happening in and around the core of the processor. But when you take in times of project, you must be able to understand the CMSIS file provided from the IC manufacturer. So see you in the next video. Thanks for watching.